Welcome everyone to our last panel. As you can see, if you're familiar with the faces on this stage, you know this is a pretty heavy-hitting panel. But on that note, I'll hand this over to our moderator, Bruce Pittman, who has been introduced many times before, but we all know him here. And he's also, in addition to everything else you've heard about him from his other introductions, he's been the programming director for this conference. We've been having weekly telecons for almost the past year, forever. To try to make this conference happen, and we couldn't have done it without Bruce, among all of our other volunteers here. So let's give Bruce a big round of applause for that too. And on that note, here's Bruce.
You'll get your $10 later. Yeah, thanks. Can we take up a collection and buy this guy a razor? You know, just I keep, Ben needs a razor. Okay, this is it. This is the final panel. This is the one where we're supposed to kind of send you off into the, there's Charles. We're sending you off into the future here. So we have assembled a truly eclectic group here with Mr. Tagalong, here. And the idea here is, how do you wrap all this stuff together? How do you take the stuff that we've talked about and put it in perspective? And then hopefully walk out of here with some ideas or some thoughts or some direction that you want to go, whether it's saving up your lunch money to go, buy a ride on Virgin Galactic, or something that you want to do in the nanosat thing on the nanoracks, or just something. Whether you want to go out and give a talk at a school and inspire the next generation. But what I wanted to try to accomplish a little bit with this talented group of people we had here is, you've heard a lot of interesting ideas about technology and capabilities and new ways of doing business and a lot of these things. So what I wanted to do was a little bit of a thought experiment here. Is if we could take these new things and these new ways of doing business and put them all together and point them in a direction like Rick was talking about in this morning, and execute it, what could we accomplish? And so that's what I charged the group up here to look about. Look in the future, and everybody's talking, well, the future, I thought 10 years was too short and 20 years was too long, so what we focused on here was 15 years. So in the year 2027, what will we be able to do? What kind of capabilities will there be? What kind of world will we live in? And how do we get from here to there in the most advantageous way? So let me introduce briefly the panel up here. So first, behind me, Jim Caravella is the Chief Operating Officer for Shackleton Energy. I think you've heard a little bit about Shackleton and kind of what they're thinking about before, but I found Jim to be a really interesting thinker, and certainly if you want bold thoughts of the future of what it could be. Now, it's kind of a temptation to just turn some of this off, and I have to admit that I'm guilty of this, well, that's just insane, that will never happen. But having talked with Jim, some of the things that we may have dismissed as not possible in the past. So I'd like you to keep an open mind here and allow yourself to just listen to kind of what these folks are going to say before you start dismissing this stuff as science fiction. Next we have Ed McCullough, is an old friend. Ed has been everywhere and done everything. He was with Bechtel, he was with Rockwell, he was with Boeing, and now he's off doing new and wondrous things that he will mention. We have, and Jim Muncie was not able to make it for some health reasons, and so he sends his regrets, and he sent us Charles to stand in for him. So just, you think Charles, just think Muncie, just.
Oh, thank
you. Then we have Henry Vanderbilt. Henry has been for the last, almost 20 years now with the Space Access Society. If you've never been to those meetings, they're fantastic. If you really want to meet the guys that are out there, tinkering with the rockets, making stuff fly, Space Access in April is a great place to go. And finally, Pete Worden, Dr. Pete Worden, General Dr. Pete Worden, who's the director of the NASA Ames Research Center, and he's my boss, so I should probably watch what I say here. Pete has... Pete has been such a champion for this whole community over his entire career at some, risk to that career. But he's certainly been a champion and a forward thinker of this. And so I'm going to ask Pete to go last here and kind of sum all this stuff up and send us out the door to the gala with the right attitude. So let me turn it over to Jim, and then we'll try to save time at the end of this for questions, and then we'll get you out of here and on your way.
Okay. Hi, everyone, and last session of the day. And let's get stuck in. Who here has heard of Shackleton Energy Company? Oh, that's a good amount. Well, here's what I'm here to tell you about, and we are actually going to go ahead and do it, and all of you are going to get involved as well, whether you like it or not, whether you know it or not. This is going to be a community drive of great proportions as the industry, the commercial sectors, and governments around the world come together on common interfaces and standards as we push forward. So infrastructure, industrial infrastructure in 100 months. That's not an arbitrary 100 months, that's 100 months starting now. The clock is ticking and we are ready to go. Shackleton Energy's bottom line is to utilize polar ice located in the craters of the north and south poles of the moon, take that volatile mineral, extract it and place it in our propellant depots in low Earth orbit and beyond for sale to commercial and government customers worldwide. And how are we going to do that? So I'm going to dive straight in because I've only got a long 7 minutes. So I'll go straight into this and we'll go Q&A later. Traditional space models start off with political or stakeholder constraints driven by constituent and stakeholder values and requirements. This is starting from the wrong end of the spectrum of the decision model. Minimal budgets are usually allocated for these processes, and constituent technologies available in local regions are then utilized for the projects that can be made. In the end, missions, in themselves, great technology, run by great people, built by great engineers, are isolated, arbitrary missions that have no contiguous sequenced value in the long term and in infrastructure scale. What this means is that on the very long terms, we have a strategic leadership void in our global space community. As a civilization, we do not have a clear strategy of what we are doing on the space side. The results of that strategic leadership void means that every project that gets undertaken has an extreme optimism bias in its engineering proposals. That optimism bias, coupled with a budgetary constraint, because you're trying to do as much as you can, but you're trying to do it with as little money as you can get away with for approval, tends to leave, in the end, a feasibility gap in your programmatics. Your mission is compromised, and the program ultimately does some great things in isolation, but opportunities to do so much more is then lost. This results in programs that have high quality assurance requirements, extreme risk environments, no ability to take on systematic risk and spread that risk across a system. And this ultimately involves and results in a loss of opportunity, a loss of time, and a loss of economic development. If you then compound that methodology and start building multiple programs and projects with that philosophy in mind, you find that you undertake a model. Sometimes it's called, without infrastructure, it's called an attrition model. With infrastructure, it's called the Silicon Valley model. And it's an important distinction to understand. The Silicon Valley model works for many technology, biotech, and other types of projects because we have tens of billions of dollars of infrastructure established over the last few decades, if you look in computing and biotechnology and other sectors and areas. Coupled with that, you have a deregulation and the liberation of those capabilities, standards, and protocols that allows commercial sectors to go and compete and develop programmatics. So what you need is some real leadership to change the mindset and the paradigm. And the paradigm has been fantastic in the space sector for 40 years. We've done some great work. And people have done what they have with the limited budgets, with limited political mandates, but now it's time to move on and develop. We all know this in this room. We've heard some great presentations the last 3 days, and over the last years, and even over the last decades. We all know what needs to be done. And now is the time for us to actually go ahead and do it. So Shackleton Energy is going to take that leadership. We have thrown off the table all of the technology assumptions that we have, all of the political requirements that exist, all of the expectations and preconceptions that we have in the space sector, taken all that away off the table and focused on one thing. Who is the customer? For large-scale infrastructure, who is the customer and what is the market? And then who are the customers of those customers? And what are the interlacing markets that then derive out of that? And that's a challenging set of models to develop. We've spent several years working on that. Only once you understand that market can you then develop the business models around that. Once you have got those business models in place, at that point, you can start looking at the technology. So in the last 40 years in the space sector, we are all to blame. We are all guilty of being completely enthusiastic and nutty about what we do. We love it. That's why we're here, as Reverend Rick would say. But those first three pillars of what we undertake are vital if we are to mature as a sector in an industry beyond government contractors and nipping at the heels and eating away at the edges of commercial viability and possibilities. So we need to go big. We look at every industry that exists on Earth: computing, mining, oil and petroleum, clothing, agriculture. These are multi-billion-dollar sectors that have been allowed to grow and pursue profitability and growth. So let me push forward. We take that infrastructure model and we have passed it down into the components required for growth, profitability, sustainability, repeatability of the programmatics, the technology engagements into those systems, put all of those variables together and model multiple scenarios and alternatives. You can apply those models and understand the economies that come out of that system, both at the level of the organization primarily involved and then the subsequent streams of models that you see. And we can see it from multiple ventures throughout history that this model holds and these attributes remain true to all of them. Columbus spent several years generating financing from Queen Isabella. He actually went around all the courts of Europe. It was actually Louis de Santangel who gave him some key catalytic funding, and only then did he get his major financing in place. But all the roots of then the technology, the acquisition of the ships, the fleets, the crew involved the same process that we run through today on large-scale programmatics. And that allowed a return of investment, both in terms of immediate monetary goals for the crew, then increasing trade, increasing development, and ultimately new countries for the main sponsors. We take transportation. We can look at Vanderbilt. He sacrificed and basically turned over his steamship business and empire and built a railroad empire that spanned across the Americas, North America. And he employed common standards. He developed acquisitions of other companies and pushed out the frontiers of his business operations across that sector, utilizing many of the same principles that were involved. And the returns of that were once again dramatic. His net worth went over 1% of the GDP of the US. But if you look at the culmination of the benefits and the attributes that that business derived, not only for the business, his business, but for then subsequent hundreds and thousands of businesses that sprung up, once again influencing at the national and nation-state level significant returns in the equivalent of billions. Finally, in one more example, Rockefeller, new oil fields, massive acquisitions, so much so that his entire oil infrastructure company had to be broken up into 30 or so smaller companies, each of those mega giants in today's valuations. He had to deal with legislation, regulatory processes, new land, new opportunities, frontiers, many of the same principles that we have to address in our space endeavors as we push out onto new returns. The underpinning of that was new industry, new infrastructure, aviation, and indeed, today we have a $6 trillion energy infrastructure on the planet. Finally, if we just look at the internet today started from the liberation of the ARPANET protocols in the 60s. From there, we had TCP/IP, the World Wide Web, computing, the dot-com bubble, and then we now got mobile internet and ever faster broadband. You can take any number of milestones on this. But would it be interesting to see, what if the internet took the same governmental pathway as the space sector has done over the last 40 years? And this is going to be fun. We would have the government telexnet established. Mainframe interconnections in the 70s. In the 90s, we'd have districts competing for contracts for their mainframe computers. In the last decade, we would have computing tourism taking off. And people would actually be able to buy a ticket and go and see computers in their own hometowns. And finally, the government COTS, Computing Operating Terminal Systems program. 2 winners are announced, and they actually have mobile terminals that they've been able to develop. Those 2 contractors worldwide in the States have developed mobile computing units. Now, it's a little bit tongue-in-cheek, but you can see, you can try and imagine the corresponding development. Conversely, if we had the space sector being developed with the same liberation and deregulation as the internet sector, who knows? For example, let's say X15 design protocols in the late 60s were released to certain commercial organizations in the US, and that they were allowed to design systems around those protocols. 10, 20 years later, we might have had single-stage to-orbit, multi-cycle vehicles. Common standards and interfaces would have been absolute paramount, and those would have caused a widespread growth of programs, businesses, and capabilities, allowing colonization of near-Earth space far more rapidly, to the point where we are mass-producing space cars. You can take them off from your local district, much like you'd have your own little small plane today. Shackleton's architecture involves the leadership, the technology, the business, the market modeling, the analysis, and the teaming, most importantly, to take this forward. If we just look for a moment on that leadership, we have undertaken autonomous robotics development. We have led expeditions to some of the most remotest regions on the Earth and under the Earth in long-duration, extended, isolated, extreme environment missions. We've taken that ability to develop teleoperated mining, autonomous robotic systems, expeditionary ventures, and you have basically the backdrop of an architecture of a human robotic system spacefaring team. And if we take that architecture and you take that capability, 100 months from now, you can start kickstarting a common interface and standards architecture that has an infrastructure built out of common elements, all plug and play, built on production lines, fully manned, fully human capable systems that include depots, transport systems, habitations, cargo modules, and any number of vehicles and systems that you would build today for terrestrial businesses. You go out and purchase a truck, you don't really worry about what kind of rubber they've got on their tires or what is the metallic stresses on their tanks or anything like that. As a customer, you want the service and you want the business opportunities that can derive out of that. The challenge is getting over this hump. Many of us know all of this in theory for several decades. How do you get over this hump from where we are now to this infrastructure pathway? Well, Shackleton has modeled that. We do know how to do that, and that's what we are working on, securing our first phase as we push forward right now. And those architectural elements form the bedrock of a new infrastructure of rapid space development. And we can take those previous blockers to this infrastructure development and turn those budgetary constraints into growth and reinvestment, and turn that optimism bias into market-driven requirement. And from that, the feasibility gaps that we've had to suffer on an infrastructure scale now turn into exponential growth opportunities. And we take that bedrock of architectural elements, build a propellant depot business, which is our architecture for our primary business unit, and on the back of that, you have a multiple interlacing market segment-driven business that can have dozens, if not hundreds, of business opportunities springing out from there. All that has previously been science fiction, economically unviable, and we have no idea how to get off the ground, now has 90% of its common infrastructure and development cost cycles already taken care of by a profit-making venture. And those businesses and those markets can serve each other as well as end customers elsewhere. And that interlocking business capability allows us to now create a brand new expansion in space before 2020. So we are taking that leadership and we are building a future that we want. And that is the way we make the future that we want, to cover tourism, commerce, economic growth, settlement, expansion, transport, better health on Earth, power, water purification. The population requirements for 10 billion people mid-century can now be met by genuine access to in-space propellants and businesses that will allow us to get to the moon and beyond and establish a foothold to the stars. Thank you.
Is this on? Yes, I'm Edward McCullough. I've had the fortune to actually work in aerospace since the 80s and to work on advanced technology projects in Rockwell, where I actually got to run skunk works in fluorochemistry and other things. I actually worked in Boeing too. There I ended up working on special projects for the CEO, and also I worked on special projects for the CEO of Rockwell. What I'm going to talk about are a couple of things that are outlined here. Number one is how to use technology that we already have and put it together in innovative ways and what we can do with it. And the other thing is, like, not only technology, but what about organizations and collaborations? As far as technology goes, one of the goals that I've had for many years is space solar power and also private lunar missions. We almost managed to get a private lunar mission off the ground with about $700 million about 6 years ago, but that fell through. We're trying to figure out how to do that again. And that would have been completely private without NASA being involved. But the opportunities we have right now with the technology that we've got are autonomous systems, which means that if people are actually in space putting things together, it's going to be quite expensive, but if you can get robotics to put things together and to solve problems for themselves, as in autonomous systems, it's going to be a lot cheaper. Also, something that's possible with the technology we have are self-organizing systems. The thing that I'm trying to do on that is to come up with ways to use robotics to build things in space with no touch labor at all. That's been a goal of mine for a long time. The other thing is space solar power systems, from my point of view, are going to be very useful for solving problems we have on Earth, bringing more energy, electrical energy, which would come out of that, is energy that can be directed quite easily. So the amount of electrical energy that's available to a culture actually directly affects their prosperity. So if we're able to build space solar power, we're going to raise the prosperity of everybody in the world. Another thing that's happening in the future are biotechnology breakthroughs in health, technical control systems. So if I were to ask everybody a question about when do you think that we would actually be able to have living brain cells control, for instance, the stability of a flight system? Anybody have any ideas? Anybody think it'll be done in 10 years? 20 years? One person raised their hand. It's already been done. It was done in the around 2003. And what it is some people are actually working with brain cells that are on, rather on microscope slides. They're hooked to integrated circuits, and they're able to take information about the flight control, get it to the brain cells, and they can actually stabilize a simulation. So if you knock the simulation, disturb it, they'll put it back into stability. That's already been done. How many people think we'll be able to look right out through the eyes of a living cat in 10 years? 20 years. It's already been done. Dr. Yan Dang here in like San Francisco area has already done an experiment where they put up 100 electrodes into the brain of a cat, and they're actually able to walk in front of the cat, and you could actually see the shadows of the people that were in the experiment moving in real time. What that means is that eventually we're going to be able to actually put information into the visual cortex of a person. And the thing that I'm quite excited about is the fact that sooner or later we might actually be able to take people that have had vision problems, vision impaired, and make them see again. Other things, how many people think that we'll be able to go to like a human being that doesn't have to breathe? That's not already done yet. But there's technology coming out of Harvard where they're able to actually use titanium dioxide films under ultraviolet light and electric fields to split oxygen and hydrogen out of blood. The oxygen goes this way, the hydrogen goes that way, and they're able to catalytically combine it with CO2 to make hydrocarbons again, or carbohydrates again. That means eventually we'll end up with technology where you can supply power to the human, and it'll actually regenerate the oxygen that they're breathing and reuse the carbon dioxide. And so that's technology that's already starting. It might actually be near term, say within 10 years for certain levels of performance, but there's a very interesting paper that's been written on that. The technology, I read through it since I know quite a bit about chemistry, is very, very impressive. Another thing is, how many people have heard of respirocytes? For those of you who don't know, imagine being able to dive underwater for 4 hours, go to sleep, wake up, come back to the surface for 12 minutes, and then dive underwater for another 4 hours. That's better than a Weddell seal. That technology is not available yet, but there's quite a bit of money going into developing that technology. That's nanotechnology that isn't that complicated. How many people think that we'll be able to have buildings that assemble themselves within 10 years? Cal Poly Pomona basically started, the architectural school, started a series of what you would call studio courses based on a briefing that I gave at the ISDC, at, I guess 2007 or something like that. And what they came up with is the idea of redefining the brick. So essentially what you have is a brick that's ambulatory, or what you have is a brick that can be picked up and moved around by a robot of some type. And what you do is you give each brick an IP address. Then you have the robotic ants go pick the bricks up and stack them up and shim them the way they want, and you watch as the building goes up. And when you're finished with the building, since it's made out of electronic bricks, or at least bricks that have some intelligence, it can actually be disassembled and used for something else. Now, if you were to take that concept and instead of having bricks, make them smaller, say for instance, down to 1 millimeter, then you have the idea of nanotechnology where something changes from a chair into something else. You scale it down again to 1 micron and you have Terminator 2. So the technology for that is going slowly. Also, we have something that's been black since about 2002, and what that is called is self-assembling nanocrystal superlattices, or self-organizing nanocrystal superlattices. That's once again technology that's heading towards the Terminator. But instead of thinking about the Terminator, just assume that it's really the Borland spaceship. Or you have a number of technologies that you use, and when the technology becomes obsolete, the case just turns into the new technology. Additional things here. Right now, robotics, within the next few years, we're going to be able to have robotics where the ambulatory systems will be able to do sub-millimeter precision work. That means a robot that can do things that an auto mechanic does, only better. The technology for that is essentially vision-based situational awareness, and also angular sensing devices. If you take a look on the patent database, I have a patent for a device that I got at Rockwell, and what it does is it allows you to do angular positioning to within 1 part in 100 million of a circle. And so those types of things are the things that are going to make some of these seemingly fantastic science fiction things that you see actually come to pass in a very short period of time. Politically, everyone is concerned with jobs, but if you'll notice, there are automobiles on the freeways now. I guess it's Google is doing this, where they drive by themselves right on the freeway. What is that going to do for truck drivers? Or for people who work on construction sites that work front-end loaders and other heavy equipment. So we're actually heading into a world that's going to be quite different very shortly. Let me talk about the cislunar, there are a couple of things that Bruce wanted me to talk about. The barriers to getting things done. The reason why I mention those technologies, there are population stereotypes about how quickly technologies can develop. Okay. And essentially what we're looking at is that people take a look at technology development and they look at it as being a linear thing. Actually, it goes exponentially. So you should expect to see some of these things very quickly. Also, I'm former chairman for the Space Colonization Technical Committee for the IAA. On our website, you can go and there is an actual space development roadmap, some that were done for the National Research Council. But anyway, what those things have are large numbers of people in space within 20 years. We've always looked at 10,000 people. We might not make that, but we certainly want to do better than 4 astronauts. 6 astronauts. Also, then Pete Warden is sitting here. Pete was involved in something that was pretty spectacular. Some people say it was some of the best engineering team ever assembled in the 20th century. It was essentially a skunk works. The way they actually managed to get significant work out of these people was they had a badgeless organization, sort of like what we had on a nuclear submarine. People had ranks, but that didn't mean anything. People actually went to the people that knew what they were doing, and there was another hierarchy besides the official one. In a badgeless organization, people can solve problems. If there's an organization that's full of protocols, then, for instance, like the problem at Fukushima, in that culture, if you're at this level, you cannot criticize someone who's above you, which means you cannot react and solve emergency problems because there are problems about who you can talk to and what you can say. But in any case, I would say that these barriers are all coming down, and that within the next 20 years, we're going to have technology that's going to keep going the way it's been going. We didn't have, smartphones 20 years ago, or 30 years ago we had the Princess phone. And you can expect to see that exponential technology rise continue. And you'll see it in healthcare, you'll see it in space infrastructure, and you'll see it in energy from space, and you'll see it in manufacturing on the Earth. And I guess I can wrap it up with that. Yes.
So, Charles?
I'll try to keep my comments short, and since I'm replacing Jim Muncy, let me see if I can talk about a few things that I think Jim would have talked about. First of all, there's a number of phase shifts, paradigm shifts coming, and waves. And so first, I'll mention with my good friend George here in the front row is 15 years from now, you're going to see thousands of people a year going to space, suborbital, and you're going to see hundreds of people a year going to space, all private passengers, all the way to orbit. It's going to be totally commercial, and it's going to have a huge paradigm shift in thinking about what space is involved in. George is going to have a big deal part of it at Virgin Galactic and the other companies that are in this industry. It's going to be a really big deal. And we're going to be talking about amazing possibilities based on all these private citizens going to space. And space tourism is a huge market. The tourism industry on the planet Earth is one of the largest markets in the world, and it's just going to be seen as a natural extension, natural thing to do. In fact, if you go back to the foundations of America, the Virginia Company was founded in part based on tourism. Many of the people, how they paid to come to America was these very wealthy people who paid to come check out this new land that they named Virginia. And so it is a fundamental business market that is great to build in. Another wave for you to be building in is CubeSats. Moore's Law, CubeSats is a reflection of Moore's Law. Nanotechnology, computational biology, all of these revolutions go in place are all going to come back and reflect in CubeSats and I think in RLVs. The materials that are coming, the computations coming, putting in the hands of the average American engineer and building lots of hardware is going to have tremendous implications. The other thing is changing the business model. I think part of what happened, if you go back to 1987, Rene Anselmo broke the monopoly on Intelsat. Huge innovation in the next 10, 15 years in telecom. You had digital satellite radio, you had cell phones, you had digital television, you had amazing innovation in satellite telecommunications. 15 years later, it was a $100 billion industry. What happened a few months ago was COTS, a private company, docked with a space station. Nobody believed they could do it. That is, I am seeing the shifts in people's attitude in Washington, D.C. and across NASA and across the country. It's like, it changes your thinking. It's your paradigm. We're going to see major implications from this thinking. The business plan competition, there were some big surprises yesterday. There was a company that put forward that may have solved the radiation problem for humans using biotechnology. If that actually works, you know, the biggest barrier inside NASA, people says why we can't send humans to Mars is radiation. If we actually had a commercial company come to this conference with a NASA-funded prize and we solved it, that's a big deal. So there is a convergence of things going on here. I think there's huge opportunities for those of you who are entrepreneurial in nature. This is a great time to get in. You know, you are talking to some of the leaders of the revolution and people who are going to make whole new innovative things happen. And I just think this is kind of, this conference and the people in here are the nexus of collaborating and putting these waves together. Some great things are happening. I don't know exactly what they are, except for what I've already said. You're going to see talk about robotics. You're going to see robotic satellite servicing in orbit and assembly. That's just amazing. The convergence of robotics and intelligence. Mark Andreessen talks about software eating the world. Well, that shows up in intelligent systems and robotics. You know, the Vivisat model over here, Jim Armour's over here, you're going to see some really amazing things that if they get their business going, they're going to have the several generations beyond that are just going to be amazing, what you can do with robotics in space. So I'll leave it at that and get forward to the discussion.
Thanks, Charles.
I'm Henry Vanderbilt. I'm going to try to talk fast because I realize that a couple of us here are the last thing standing between you all and the bar. Bruce was kind enough to mention the Space Access Conference I run. A quick plug there. Best short description I've heard of it is it is an incubator for space transportation ventures. Happens every spring, mid-April in Phoenix. keep an eye on our website for the details on the next one if you're interested. You don't have to be ready to start your own space transportation venture. The process is pretty interesting. You might be willing to work for somebody else there. You find out all sorts of interesting things in the process. On to the subject of our panel here. I'm not going to try to predict what's likely to happen in the next 10 to 20 years. You know, your guess is as good as mine. What I am going to talk about is some practical advice on how those of us here who are trying to help make it happen can maximize the chances that our efforts will pay off. There's a number of ways people here in this room can be involved. A lot of you here are either thinking about or already working for space ventures, new space ventures. There's also, some of you are thinking of starting your own new space ventures, but if you have that big an ego, you're not going to listen to me. But there's also a new investment regime that just came along under the Jobs Act last year. There's been something around called Kickstarter. There's been crowdsourcing. There is now a mechanism so you no longer have to be a qualified investor with a minimum $100,000 to burn to make an equity investment in a new space venture. A lot of people here may have actually thought, and if you haven't, you should have, taking what you might have spent on your next vacation somewhere interesting and putting it into an investment that might do some good and might pay off for you in the long run. Anyway, I'm going to talk a little bit about maximizing the chances those things will pay off. I've been watching this industry the space industry in general for my entire adult life. But you don't need me to tell you, some of the venture capitalists who were earlier told you that the vast majority of new ventures, new space or wherever, are going to fail. What I can tell you from my experience is that a fair number of them are going to predictably fail. There are things to watch for. There are things to know about which ones have a better shot at least. There's no guarantees in this life. No, I'm not going to name any names. Lawyers give me the hives. But there's some general principles to keep in mind while you're looking at getting personally involved in putting a little bit of your personal skin in this game. There's some fairly timeless rules. Just in general, anybody who's starting a new space venture will tell you about their grand vision. They'll have a wonderful animation of the final product. They'll have all sorts of charts and graphs about the revenue they're going to be bringing in. That's great. Everybody has that. You also want to immediately go to look for the step-by-step plan to get there from where they are currently. And preferably where they are currently will have involved actually accomplishing a few of those initial steps. In addition to the glorious graphics of their future vehicle, you should see, say, a few initial propulsion tests of some technology demonstrators for what's going to make the vehicle run. Photographs, not computer graphics. And you want to look for the step-by-step plan and some evidence they're going to do it, not just the grand vision. Some more general principles that tie into all of this. A timeless law, I think it's originally called Cheop's Law, but it goes back a lot further than the old pyramid builder. No matter what your original plan, everything's going to take longer and cost more. It's not always true. Occasionally things come in ahead of schedule and below budget, but it's sort of shocking when that happens. Most of the time, the surprise is going to be on the upside. You should be ready for that when you go into things. There's some reasons for that, too. Nobody gets into any of these ventures who's not an optimist. Generally, if you had actually seen a realistic projection of what it's going to cost you in time and money and effort before you got in, you probably would have gone off and invested in the internet instead. Sheer optimism is one reason why things tend to take longer than planned. Another reason is Murphy's Law. Anything that can go wrong will go wrong, and a lot of things you didn't think could go wrong will still go wrong. You can fix these things. It takes time. If you're looking at a project to get involved in, look for people who seem to be accounting for that and ready to deal with the unexpected. Ultimately, the thing that'll bite you is what I think it was Caspar Weinberger called the unknown unknowns. The things that you don't know that you had no idea were going to pop up and be a factor in your particular project that came up 6 months into it, and it surprised the heck out of you and caused you to spend some number of more months pursuing that particular track, figuring out what was going on, and then getting back to the main path. That sort of thing will bite you. But again, I'm trying to get you to the bar, so I can't give you a lifetime of experience here. I can hit some of the high points. My consulting fees are very reasonable. Actually, I'm not in the consulting business. Buy me a beer in the bar. Another timeless principle for this that very much applies to this industry is that propulsion is the long pole in the tent. It's the aircraft industry. They said it's the engine that's the long pole in the tent, but we're talking aerospace now and rockets. Trick question: when did the Wright brothers first fly? 1903, right? No, 1900. They started flying gliders in 1900. By 1902, they had a vehicle flying that looked remarkably like their first Wright flyer. Why did it take till 1903? They didn't have an engine yet. That, more often than not, in any new aerospace vehicle since then, if you look into it, unless they were designed to fly with an existing proven engine with no variations and no tinkering, which is rare because how do you get a performance advance that way? They tended to be delayed for, waiting for the engine to come, or to fly with a lesser interim engine in the meantime to get some experience. It's happened a lot since the Wright brothers. It's happening now. It'll happen again. Be ready for it. One last point, and this is something that gets overlooked a lot in people's grand presentations and step-by-step plans. Aerodynamics matter. Aerodynamics will bite you. Getting into space involves going very fast through the atmosphere, or, well, balloon launch from 100,000 feet sort of bypasses that, but that has its own problems. Mostly it involves going very fast through the atmosphere. Transonic aerodynamics, supersonic aerodynamics, can get very exciting. Transonic can cause your vehicle to suddenly fly sideways when you weren't expecting it to. Supersonic can suddenly make your vehicle brake when you weren't expecting it to. Step-by-step plans for vehicles that are going to do this, especially reusable vehicles, winged vehicles, should include CFD and wind tunnel testing and a flight test program, and some time to fix the surprises they find in the process of all of these things. As I said, it's been going on for a long time. It'll continue to go on. Aerodynamics will bite you if you try to ignore it. I could go into some instances, but again, we need to get to the bar. Just in general, if you're going to get involved, if you're going to put your personal skin in the game, try to maximize the chances it'll pay off. As I said, the rules up until very recently was you had to be well enough off that you had $100,000 that you could essentially burn and walk away and not be the worse for wear. The majority of ventures you put your time and money and sweat into, you'll still end up at the far end of it with essentially it will all have been burned, and you'll have nothing but whatever you learned and whatever the entertainment value was. But there is some chance you'll have a success to point at and be proud of and be part of and carry on with. And you want to maximize those chances before you get involved. I suspect there's a lot of people here that on one level or another either are or will be getting involved, and it will be shaping the next 10 years. I'm looking forward to it. Thank you.
Well, I'm standing between me and the bar, so I'll try to be very brief here. Bruce asked in his email to us, what we thought might happen near the end of the next decade, or in the next decade. I think, and of course all predictions are wrong, but based on people that I know are working on this, that sometime late in the next decade, humans will leave this planet permanently to live on another world. Now, whether that's the lunar pole or Mars or an asteroid, my personal favorite is Mars. And I think that's going to happen. But the fundamental question here is why, and why people are going to do that. Now, a lot of us have thought a lot about what motivates people to do things. There's really three key motivations. First one is fear. That motivated Apollo. We're afraid of the Soviets. We beat their asses, but that was, but that's why we're here and not wearing, red stars and things. Second is greed. You know, you can put it in a nicer way, profit. That motivates a lot of us, and that's making progress in space, but it's slow. The third one is I'll call grandeur and or monuments. And I think this is an important one, and I think this is what's going to motivate, and this is my own personal prediction, settlements in other worlds. And there's a variety of reasons for that. You know, people have built pyramids on Earth, they've done other things. It's your only way to be immortal is what you've done and left. But can you imagine that the first city on another world is named Muskville or Brintown, you know, Bezosburg? You know, what a motivation that's going to be. Or Zion. I mentioned that for a reason. I think that this is the motivation, and it's both individuals, but it's ideas, it could be religion. These are the reasons that people do things in the past, and I think it's the reasons they're going to do things in the future. So it's, and you're seeing a lot of beginning of that today. So, you know, sometime 2027, that 2029, something that may look like a Falcon Heavy or maybe even an SLS, you know, that was bought privately. You have to remember who I work for. Will take off. It'll have a handful of people, you know, 3, 5, probably an even number, that will go to Mars, and they will never return, but they're going to settle. I think they'll settle in caves, but they'll take with them technologies that have been discussed here. My personal favorite are 2 of them. One of them is synthetic biology. It's the ultimate self-replicating programmable machine. The other one is some sort of artificial intelligence, maybe based on quantum effects. In fact, there's increasing evidence that our brains are working on quantum effects. But regardless, I think it's going to happen. And the strongest motivation to go there is what's not there. What's not there is us. What's not there is my organization. There's no government, and so that you can build a new world. And I think that that's what people are going to be doing. I think the primary product that may ultimately be valuable is what they can do in the absence of controls. Some of those are dangerous. Some of these settlements and colonies are going to be self-ending, maybe in a rather dramatic sort of way. If you're fiddling with the substance of life and the substance of intelligence, that can go wrong. But that's better to go wrong on Mars or on some asteroid in the asteroid belt than here. And those products that they produce will bring things back to Earth. So, you know, I look at that unlimited future. I think it's going to happen in our lifetime, you know, probably even mine, depending how many drinks I have at the bar. But you're going to be involved in it. This is the group of people that are dreaming about it. And just as a final, you know, best wishes to you that what NASA says to everybody that goes on a great journey, potentially dangerous one, is Godspeed. So Godspeed humanity, or whatever you are going to become. Thanks.
So let me, since we're running a little short on time here, let me go ahead and open it up for questions. So who has a question for our esteemed?
If there's anyone online that has questions, we're monitoring them.
Yeah, we're monitoring the online questions, and I will open it up here and see what they have to say. So any questions? You guys are all speechless. How about over here?
So I just wanted to ask, I don't want to disrupt the optimism, but I wanted to ask, I've heard a lot of good things about the future and what's to come. And my question is, what major hurdles do we have to get over to get there? What problems do you guys possibly foresee that will inhibit us from reaching those goals? What kind of things do we have to, what kind of major obstacles, maybe it be the Law of the Seas Treaty, whatever, what kind of major obstacles do we possibly have to get over?
I'll jump into that one quickly. The major obstacle is mindset. So significant mindset engineering is what is required. There are other challenges that exist: technical, regulatory, financial, organizational, logistics. You can run a line around the whole enterprise, and there are challenges peppered throughout that system. None of them are insurmountable. None of them have been insurmountable for thousands of years. Mindset engineering is the first one to hit.
Well, I mentioned Murphy's Law earlier. Anything that can go wrong will. Ultimately, the thing
And the
that could go
corollary to
wrong-
that is Murphy was an optimist, you know.
Yeah, yeah. The things that can't go wrong will still go wrong. But there was actually a bit more of a point there. As an old project manager, one of the things you do is, I mean, you have to try to outguess Murphy. You'll never succeed entirely, but you can often, you know, pick out things that could obviously go wrong, catch them as they start to happen, you know, stop them early, and move on. To move on to the next problem that'll come along and bite you. Ultimately, the thing that could go wrong is if we lose the will to go on solving the problems between us and the goal.
The government.
I would say the major obstacle is lack of information. I talk to people about things, and I find out that there's information that they don't know about that they're happy to learn. And if they had known it beforehand, they might have made different decisions. And I think that better information technology will have people better informed, and that will get rid of some of the protocol issues that we have that actually delay and stop the development of technology.
Well, just to go off Pete's thing, politics can always screw up anything. You know, the political process sometimes is completely irrational to what is growing a new industry, and so that can drive you off into a ditch and delay this and cause serious problems. So what is incumbent on entrepreneurial space, the entrepreneurial space community, is understanding the political process and not being reactive, but being at cause and understanding it so you can drive it rather than having it drive you.
And I guess I'd like to add one thing to that. I think, you know, it sounds a little naive, but I mean, it's kind of like belief that it's possible. That I think that we've tended to get, and I've watched this over my career, tend to get kind of jaded and risk adverse, especially when it comes to space. You know, that when you look at the grand things that we did, and maybe it was because we were naive or we were optimistic or whatever, but we tend to have gotten a little jaded. And I think so getting the belief, and I think that's what you young people are essential for, is it's really important to not know what can't be done, because those are the people that go do it. And so I think that just because it couldn't be done 10 years ago, or even it couldn't be done last year, or it couldn't be done last week, doesn't mean that it can't be done today. That's one of the things about the changes and the progress that we're making. So I think so yeah, listen to your elders, listen to your peers and all that, but you know, maybe with a grain of salt here. And if you really think that it can be done, if you really think that you understand it, get all the information that you can, but take it all with a grain of salt. And sometimes there's this wonderful line that I paraphrase from Animal House all the time at work, and you know that thing. It says, "Gentlemen, it's time for a meaningless and futile gesture." So sometimes just going and attempting something is an important thing to do here. And even if you don't succeed, you'll learn. And maybe it's not the first time, maybe it's not the second time, but sometimes the third time that you can succeed. So one of the things we've learned in Silicon Valley is failure is not terminal. I mean, unless you're doing something where it is terminal. And so you want to watch out for those kinds of things, you know. But failure, I mean, it's failure. You know, you tried something, it didn't work. You know, get over it. Figure out what went wrong, fix it, Go back and try it again. So the one way to make sure you don't fail, don't give up. So anyway, how about more questions?
This has been really overwhelming for me. I really like it. But you've talked about a lot of disruptive, high technology, things that require a lot of smarts to either develop or use. And it's going to create economic dislocations. Gentlemen talked about truck drivers being unemployed. What do you do to keep people educated? How do you reform education so that people can cope with disruptive technology?
Are you asking that we solve that?
Throwing it out, I'm throwing it out there as something as you're focused on the technology. Have you thought about how the intellectual 99% deal with that?
Okay, well, I am personally very excited by something taking place in technology and education. It's probably best exemplified by something called the Khan Academy. Flipping the classroom I think is going to be revolutionary on education. I think 10 years from now, it's going to kids coming out of the schools that are going to demand this type of education at their colleges. It's going to totally change everything. So KAHN Academy, I recommend you go look at it. It's this gentleman who just started on the internet and YouTube, and millions of kids are now taking his classes for free online. And I'm using it with my second grader, 8-year-old girl. She's like doing 5th grade math right now, and it's only because we do it at home, and her school is slow. But everybody's going to be doing this here pretty soon. So I think it's going to. Technology is disrupting the classroom right now. It's starting to take place, and that's going to be a major part of the revolution.
Yeah, maybe I can answer that in 2 ways. One way is the way Charles talked about is you persuade people it's a good idea to do disruptive things. The other thing is just don't tell them about it.
On the issue of labor-saving devices and disruptive technology, et cetera, people get up every day and they do something all day, every day, and they go to sleep. Labor-saving devices have been around and been introduced for centuries. The screwdriver was a serious labor-saving device. But what happens is people are really required for other things. You know, people working on factory floors, et cetera. There are many other things that we need for them to do that they could be doing.
So Shackleton Energy is going to have 10 to 12 industrial astronauts in space by 2019. By 2029, we expect to have over 1,000 customer and participant astronauts in space. Someone who's 10 years old, 15 years old, 5 years old today has a real running to start a business, to get engaged in that process that a generation or 2 generations has not really had the widespread opportunity. This is really happening, and this time is now to get involved in that education and that learning to get ready and get prepared.
I actually disagree with something Pete just said, that you avoid worrying about the disruptive effects by just not telling them. I think it works. It does work. There are circumstances where it's warranted.
Apple or Google or any other company that does things. Sometimes
But
you tell people about it, sometimes you don't.
I have a pet peeve about this industry and the way it's run. A lot of the people who've come into this, the NewSpace industry came into it out of the information industry, and they've carried over some habits that aren't necessarily appropriate. You look at the information industry, the concept is everything. Nobody wants to talk about their concept because anybody could put together a competent team to implement it if they hear about it. If you heard ahead of time that, what if you started a web service to, distribute 140 character or less messages on a very flexible basis? A lot of people could have implemented that. NewSpace is different. Concepts are easy. Concepts are a dime a dozen. Anybody who's got ego enough to start a NewSpace company, you couldn't get them to steal your concept. You couldn't give your concept to them. You couldn't force it down their throat at gunpoint. But seriously, the very difficult thing in NewSpace is building the engineering team that can implement the concept. It was mentioned earlier that Dr. Reuther was mentioning earlier just how high energy devices rockets are. You're running right at the bleeding edge of the materials and the aerodynamics and the capabilities. It's an extremely difficult engineering. You need a very good and exceptional team, and to do it, fast and cheap and reliably. And building that team takes a long time. A lot of the internet people in this industry are hiding exactly what they intend to do because it's just habit. They're afraid somebody will steal it. Whereas in fact, anybody out there who's got a competent enough engineering team to steal their idea already has their own ideas that they're pursuing. Basically, the industry ought to be talking to each other and to the world about what they plan to do, because they'll get useful feedback. There's useful knowledge in all sorts of places. There have been a number of flight incidents over the past few years that were aerodynamic problems, for instance, that probably could have been avoided ahead of time by talking to the right people or just mentioning we're going to try to do thus and such a way. Somebody would have mentioned, look out for this particular phenomenon. It'll bite you. And a number of millions of dollars worth of hardware probably could have been saved if people had just talked to each other more.
A good example of that was Lockheed's test of their tank for the X-33 with liquid hydrogen that caused the tank to unzip due to cryopumping. Rockwell already knew how to stop that.
Yeah, let me defend this, though, because I think that I didn't say it's the only way to do things, but that if you're going to do something new and disruptive, and we all do that. There's two ways to do it. One is to convince everybody it's a good idea and involve everybody. That's what NASA does, and we do new, cool things. But another way to do it, and by the way, another organization I worked for, called the Department of Defense, did some pretty new, innovative things too. I mean, they unlocked nuclear power, do other things. And that doing them without being interfered with is another approach. So you have to figure out what are the upsides and downsides of involving everything. And that's a key point. But don't dismiss the idea that three people not telling everybody else about what you're doing in a garage can do amazing things just as much as you crowdsource it. So, I think it's very important when you do something new, figure out which model, what's appropriate to you, what's appropriate to your organization, what's appropriate to the thing you're doing. So, I mean, again, I said that a little facetiously at first, but it is important sometimes to not tell everybody about things. I've gotten in trouble a few times because I told people about everything. Right. So sometimes it's better to seek forgiveness than permission.
Right. I want to add my concur with Pete. Is as an entrepreneur, one of your key strategy decisions is, are you going to be open and sharing and transparent? And sometimes that's the right way to go. But sometimes keeping your secret sauce secret is critical. And so you have some completely different business models, and you need to make that decision. And I recommend for those of you who are interested in thinking about this, Peter Thiel, who is PayPal co-founder, the early money behind Facebook, and LinkedIn, and he's now a multi-billionaire and very well off, and he's also a little bit of a space buff, has taught a school at Stanford this last year. And go online and Google Blake Masters, Peter Thiel, Stanford, and he's got some amazing lectures talking about the value of keeping things secret and versus some other model, and thinking through what you might do on this. So I agree with Pete. That it depends on the circumstances that what's right.
So let me add one other thing here. The question of whether disruption is good or bad. Welcome to the new world. I mean, live with it, because it's a global world, and if you aren't disrupting it, somebody else is. And so I think one of the things here is, how do you embrace the disruption? And I remember something that I heard. I was doing work with one of the DOE labs, and one of the deputy directors, we were talking about training and disruption and all that, and he said, I can no longer offer my people lifetime employment, but he said, what I can offer them is lifetime employability. And so trying to develop the skill set and all that. And one of the ones is this idea that once you get a bachelor's degree or master's or even a PhD, that you're done learning and you just can skate on that for the next 30 or 40 or 50 or 100 years, you know, depending on how the synthetic biology stuff works out. I think is one of those paradigms that's shifting here. So this idea of lifelong learning, and sometimes you have to reinvent yourself, but going out there, and that's why I think the STEM education is so important, is to have that foundation that gives you that platform that you can go into these different areas. And yeah, you may have been trained as a mechanical engineer, but maybe you get excited about synthetic biology or thermodynamics or fusion or whatever, and you want to go into that. So those especially with some of these online learning tools like Charles is talking about is now there's an amazing amount of information around there, and it's free. You can learn some amazing things, you know, with our friends from Google there. Just go in and start, you know, asking questions, looking online. So that's, I think, so disruption isn't necessarily a bad thing. It can be disconcerting. So, but part of it is your attitude toward, is this part of the, you know, a disaster, or is this the next big opportunity? So anyway, so we got about 1 minute left here. So any closing comments from
One quick comment. My old boss, Jeff Grayson, once observed that it's amazing how 6 months of engineering test can, you know, save you 2 days in the library. There's a lot of information out there, and a lot of things have already been done.
I'd like to say something about openness. Everybody in this room has benefited from the pre-competitive coalition for all optical networks. That's where everybody in the industry formed an organization, and they all collaborated on all the research that was developed before they went into competition with each other.
I'd just like to say that the risk models, the business models, the technology, and all of us here and all of you there are what is needed now to really get going where we want to go, to serve the markets that don't yet exist and the customers that are here. We can get all of this going right now, and there's no need to wait.
So help me thank the panel. And go get them.